When you hear the word particle, what do you picture? Probably a tiny little ball, a microscopic BB floating around in space. And really, that image is so intuitive and so spectacularly wrong. I'm Jason, and this is Through the Bulk, where curiosity talks back. And today, we're going to explore particles. So let's start at the beginning. Everything around you, your coffee mug, your phone, even your own body, is made of atoms. And an atom contains a nucleus and electrons. And that nucleus contains protons and neutrons. And crack those open and you'll find quarks. So that's it, right? We found the tiniest pieces of reality. Well, not exactly. Modern physics says that these particles aren't tiny marbles. In quantum field theory, they're better described as quantized excitations, or little disturbances, in fields that exist throughout the entire universe. So think of the surface of a lake. The water's always there, even when it's perfectly calm. Disturb it, and ripples appear. The electron field exists everywhere, as does the Higgs field. In fact, every fundamental particle corresponds to a quantum field. And a particle isn't a tiny little marble sitting in said field. Rather, it's an excitation of the field itself. Now, here's where the cast of characters comes in. Quarks and electrons make up ordinary matter. That's why your dog or your neighbor or distant galaxies can exist at all. And protons are the quanta of the electromagnetic field. And without electromagnetism, there's no chemistry, no vision, and perhaps, most horrifyingly, no social media. Gluons mediate the strong interaction between quarks, helping to bind them into protons and neutrons. Now the W and the Z bosons, they mediate the weak interaction, which allows processes like radioactive beta decay, and plays a crucial role in the nuclear reaction powering stars. Then there's the Higgs boson. Its discovery confirmed the Higgs field, and interactions with that field give fundamental particles like quarks and electrons their intrinsic mass. The Higgs doesn't account for most of your mass. Most of the mass from ordinary matter comes from the enormous energy of the strong interactions inside of protons and neutrons. And finally, neutrinos. These ghostly little weirdos barely interact with anything. Trillions of them pass through your body every second, and almost all continue straight through the Earth as if it's not even there. So what is a particle? It's the quantized excitations of quantum fields, which is the substrate of reality. And frankly, I think that's one of the most beautiful ideas we've ever discovered. Because the deeper we look, the less the universe looks like a machine made of tiny gears, and the more it looks like a collection of fields that are interacting and vibrating. And honestly, that's a hell of a lot cooler than a bunch of tiny balls floating through space.